This conference will now be recorded.
Hello, everyone. Welcome to HHCA's, the Hamilton Hall Construction Association's Webinar Wednesday. My name is Aaron Gorka. I'd like to give a shout out to Sue and Alana and the rest of the HHCA team for kicking butt throughout this pandemic and making sure that we all always have what we need as members. So thank you guys, and I think we'll get started on that.
Good morning, everyone. I'm Alana. I feel like everyone on this call knows me. Thank you, Aaron, for those very kind words. We're excited to get going this morning with our second installment of our Webinar Wednesday series. We're really working hard to come up with content and material that is valuable for you guys, and that's quick and easy to digest. I wanted to just mention before we start that on November 18, we're going to be getting an update from Sherard Coos on COVID rules, employee concerns, and work refusals. And then following that, the next Webinar Wednesday will be happening on December 2nd, and Wilmsden Shire environmental lawyers will be walking us through new regulations related to excess soils that come into effect on January 1st. Today, we're going to be hearing from Aeron Group about viral control measures, the things that you can do to your HVAC system to improve the air quality in your office to protect yourself, your business, and your employees. It's now my pleasure to introduce our presenter, Aaron Gorka. He holds the title of Innovation Manager at Aeron Group, a family business focused on HVAC and building automation systems. Specialized in installation and service, Aeron is a preferred sub-trade to Hamilton area mechanical firms, a reliable partner to GTA developers, and a trusted service maintenance provider. Prior to returning to the core business, Aaron led the software development and global commercialization of Aeron's tracker software suite, Ant Technologies. Aaron is a certified energy manager and holds design levels 1 and 2 from ASHRAE. He is committed to improving the health and safety of our office environments and is very excited to share everything his company has learned as a result of the coronavirus pandemic. So Aaron, take it away.
Thank you, Lana. That was excellent. You went a little above and beyond there. Yeah, thank you. Well done. I guess the most important thing for me to hit, for everybody in this webinar here is, I really do feel like this is, my duty, and as well as other HVAC and control contractors, to provide all the information we can to society members so that we can be safe and protect ourselves from this mess, and at least stay open and keep as busy as we can throughout it. I think everybody here is, thank you for your time, especially. It shows that you do care. We're going to start this. I usually start my presentations with a setting the stage slide. And what I want to do is gently walk through the last, say, 6 months. We're not going to spend much time here. I'm going to let your eyes kind of absorb, what you can see here as well. We're going to focus on government, news, ASHRAE, Aeron as what we've been doing through the process, and some of the technology variables that we've come across. Once we get through this, we're going to cut into 4 viral control measures that and present some considerations and some pictures for you. This will be informational as a webinar as a whole. So we really remember, I'm going to draw your eyes right to about March 12th, March 18th to start. That was really when all this kind of happened, and we started to close, get home and no more work. Basically work from home started. A month before, Trey had gone through Ashtray had gone through and reverted a previous stance on aerosol spread from not very likely to likely, essentially. If you jump ahead to April 14th along the ASHRAE bar, that was when they reaffirmed it. Yes, this is highly likely enough to warrant consideration in your air quality systems. So this was before summer, and when we were really just getting into this, one of the attentions I want to draw here is the speed to which technology and engineering communities have evolved. It's typically a slow measure and methodical process. and they've moved exceptionally quick to release pandemic guidelines and do the best they can. That shows the seriousness of this, as well as the reality that we're learning all of this in real time, from the doctors to the news through the government, and I believe everybody's doing the absolute best they can to provide this information. So I'm going to hop ahead here. If there's any questions to which anybody wants to talk to about this process, I would tell you that in May 29th, that was when Aeron really did get our first purchase order for a viral containment zone in a client. We started this process March 12th. As soon as it closed, I called a couple contractors in the U.S. that work in hospitals, and I started basically with the thought that whatever they have in hospitals and maybe tuberculosis facilities, is really what we could look at commercially. By the start of the second half here, we'd had one purchase order, and we'd been promised about 10 weeks delivery on UVC technology. By the next month, it was clear that the deliveries weren't going to be met, and we're still waiting on these. It was 10 weeks originally. We're into about week 20. Overall, this has been quite a journey, and I think that ASHRAE at the beginning of June and mid-August opening their building release guide, they haven't had to do very much since then except evaluate. And you can see that's also where Aeron really started to ramp up to, and hosting webinars and start informing people and doing campaigns that started to work. To date, for local school boards, we have gone around and provided more fresh air into all the schools that were part of the project. We've begun fit ups on and creating pandemic sequences of operation all around ASHRAE guidelines that I'll dive into here. So there's a process here that we got to roll through, that involves temperature and outside air protection, and the ability towards it to achieve it overall. If there's anything anybody wants any questions about with regards to that timeline, my purpose of it really was just to walk through the evolution and again show the breakneck speed and the different evolutions of these technologies. Okay, there's 4 steps, 4 options that are mainly applicable into your buildings to protect yourselves. They kind of go in sync with an ease of application, with standalones and portable units being the exception. I believe those are more residential solutions, but the first thing that came out was MERV 8 to MERV 13 filters. If you're using anything less than MERV 8, I mean, you can see through those. They're very cheap filters. They're not catching very much of anything. I will get into a slide that shows you the efficiencies of MERV, the MERV ratings as well, in a little bit. In the end, what happened with those is you can't. They're about 18 weeks or say 10 weeks delivery on them now. They're back ordered everywhere, and the material's not available. Overall, it's not an overly effective solution alone against COVID. The number 2 recommendation related to building controls, simply increasing fresh air and controlling your humidity. I say simply in theory. In reality, the amount of fresh air that you can pump in through a piece of air handling equipment is very engineered. As it gets too cold outside, you can freeze those coils, and not having the correct safeties. Most of that equipment is surprisingly or not surprisingly not functioning as well as you would expect it to, or as that it needs to. As well, every little bit of fresh air, hot air, cold air you bring in needs to be heat and or cooled. So the energy costs associated with fresh air alone are extremely high. Controlling humidity entirely depends on the capability of your system. Many rooftop units, the small ones that you would see on top of strip malls, don't have that capability. They're usually bigger units or have fit ups within the ductwork where you'll find humidification. It's also extremely expensive to perform, maintain, and do right. So you'll notice I have a $sign beside option 2. It is expensive overall. They are fast wins if it's capable, but it is not your cheapest solution. Where I really want to focus here, this webinar, is the high-tech viral control zones. We started with one technology being the UVC. We later learned about the ionization. And then very recently, through an article in the Spectator and some research at Mohawk, we came across a combination UVC ion plus 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 solution. It's the one in the bottom right here. I joked with my friends last night as I was hashing through this presentation that I'm pretty sure that this thing would produce a lightsaber the way it looks. I'll jump through some considerations now. We discussed many of them, but it's good for you to be able to read them. Generally speaking, HEPA is too strong for most commercial air conditionings. Unless your system's designed for HEPA, the pressure drop across it is too much to be effective. You won't get any air to the end spaces you're trying to serve because the filter is too effective for the motors. Talking with filter suppliers and other recommendations throughout probably March or April last year, we learned that MERV 13 is about as tough as you can get, as big as you can be on it. I would also say that MERV 11 turned out to be a recommended alternative. Overall, MERV 13 is about 3 times as costly as MERV 8. So if you're used to buying like the normal 2-inch pleated filters, that's probably a MERV 8 filter, and the MERV 13 is about 3 times as much as that. MERV 13 catches approximately 31% of a flu virus. So they have a similar size in diameter, the flu and COVID, from a micron and particle perspective. MERV 8 only catches 10.7%. So the conclusion here that we can draw is this option must be coupled with something else to be effective, because 31% is not going to do it. I talked at length about option 2, which is a building controls, fresh air and humidity. You need to heat or cool all air being introduced. If you look at your energy costs and you think about maybe in your home when you open your windows, or in the summer when maybe your kids leave the windows open with the air conditioning on, and you look at your bill, this is the reality that you're going to face, but with commercial equipment. No matter what, your step 1 here, your very first action item of this webinar is to assure your economizers are functioning properly, and consider increasing your fresh air intake in the buildings. Economizers are essentially actuators and dampers that open and close based on the demand of the space. If you install things like demand ventilation sequences and sensors and technology, create the ability for demand ventilation, you read the CO2 in the space, and you can modulate the amount of fresh air that you put into each space. So I would say that that's step 1. That's what a local school board did first, was making sure that's functioning. One of the most original sales that I can remember in this industry, having been around it since I was 3, was economizers. Originally, the sale was about energy efficiency, minimizing the fresh air intake. Right? If you're bringing less fresh air, there's less to taper or temper, and you can save energy that way. And you did save a lot. We're taking this towards a viral control measure where we're actually trying to maximize the capability of a fresh air handler. If there's no questions on 1 and 2, I'm going to jump into option 3, into the high tech. The UVC fit up was the first solution we came across, finding it applicable in a lot of US hospitals. And what we liked about it was the manufacturer, the original one that we were recommended to go with, had the engineering capability and the sales spreadsheet for us to calculate the appropriate dosage based on the actual site conditions. It allowed us as a contractor to go in and measure up these fit ups and do it with the exceptionally high dosage required for moving air. UVC is not a new technology in this industry. It's been used in the past as a coil cleaner. It kills bacteria on your coils. In the southern U.S., where air conditioners are running all the time, mildew and bacteria does grow on your cooling coils. The advantage in Canada is oftentimes when they turn off in the night, it dries up, it flakes off, and it's not a problem. So this is why it's not made its way into Canada as a primary solution. However, you only need about 3,000 microwatts or micro units to kill or deactivate the bacteria on it. Because it's stagnant, it's not moving on the coils. To do it in the airstream with very high CFMs and feet per minute across, in your air ducts, you need 8,000 to 10,000 microwatts. So the coil cleaning solution that may or may not have been presented to you is not a high enough dosage. This is the most important variable to the rest of this presentation, as well as the ability to measure and understand and engineer a solution. We put together some ROI calculations and compared UVC with the fresh air, the building controls option, and the cost per fit up and putting it in can turn a 1 or 2 year payback compared to controlling the fresh air intake in your building. And again, you can engineer, in theory, the one pass or to 99 or 97% of a one pass kill rate. Light bulbs typically have about the high density UVC ray light bulbs have approximately two year lifespan. That times well probably with this COVID endeavor. And when it's time to fit them up or replace them, it's only about 30% of the cost of install. This is more or less what they look like, and I would like to draw your attention to the top right corner. This is that MERV rating that I discussed. You can find MERV 8 and go across to the filter removal rate, and then plus the UVC installation there. Also draw your attention to the size of microns for influenza A. This is what we have as a reference point based on for the UVC technology. There was no testing available. I do not believe there is yet for the actual COVID virus. It's my understanding that the COVID virus is approximately 1.12 something rather microns, so comparable in size to the influenza A. You'll notice right away that UVC is 97% effective, with the proper dosage to a 90 plus kill rate or deactivate rate of a virus. So our original solution that we provided and received purchase orders for, we're waiting for the product, is on a combination of MERV 13 filters with an appropriate dosage of UVC fit up to provide approximately 98% chance of a first pass kill rate of COVID. Your approximate installation costs can be between for very small units, where you can fit it near the coil, many lamps between the coil, is approximately $3,500 installed approximately, and it can go up in high CFM units to up to about $40,000, with the average hanging out around about $10,000 or say $15,000 per big unit, more or less, based on the science we're provided and the calculations we've learned. I would feel comfortable providing that in record. Next technology. So this I started learning heavily about this in about June. Another U.S. contractor in Atlanta, very good solutions provider named Entech, they were on this stuff as well. We worked together on a software and we collaborated closely about these viral control measures. And they were fairly convinced, and so were their clients, on this ionization technology. It's, again, not a novel solution to HVAC and control. The applications range, diverse. Essentially, it works by positively and negatively charging the air molecules to, first of all, make particles bigger. This does increase the filter effectiveness, and research shows, under very strict conditions, that this can dismantle and deactivate the COVID virus DNA. The second point I want to really hit everybody's attention here is the research under very strict conditions. So as even the UVC rolled through, we had another supplier manufacturer approach us because we were looking for other solutions, of course, to provide, with long lead times. And they sent us this information, and without reading the research and the fair test, which constitutes this ionization as well, was a closed box with a fan, with COVID or with a virus, exposed for 60 seconds to an hour. And he sold it as a COVID solution. And the problem here and the diligence that needs to be taken to the detailed research is vital. In the real world, air conditionings are moving fast. You're going to get a split second exposure to these viruses. So this is the important portion and the research and the diligence that I want to bring to your attention when you're considering these viral control measures. The other thing I'm looking for from the research is, like the UVC, a firm number or a measurable number of say ions that will deactivate the virus. Like how effective is, say, 10,000 ions versus 100 ions, right? Given a certain amount of CFM in a general occupied area of X and Y with this amount of people. So that's something that I'm looking forward to in learning more about, I would say, about this technology. Based on the feedback, positively from a perception perspective, there's a big there's a noticeable difference in the air, in the way it smells, and the way it feels when you use the ionization technology. I was in Atlanta a few years ago and bought one of these ionizers, like a little portable one that plugged into a wall. I wasn't staying in a very nice hotel, and the air quality was very poor. And I did plug it into the wall, and I put it on the little wall unit, and I did have a very perceptibly, noticeably different improvement in the air quality. So all variables to understand. I believe that this is a more affordable solution overall than the UVC. I'm not sure about the effectiveness of it yet, based on, again, science and research. Here's some examples. You can see if you have big air handlers with big cooling coils, you can strap 2 of them. It's fairly simple install overall by a qualified electrician. I believe it's low voltage, or I believe you can get into the 120 volts. There are different technologies. This in the bottom right, these little bristles I've highlighted, that was the type of portable one that I had bought for the hotel room. They come in rollout strips, more commercially sized zappers. We'll call it bristle zappers, and a couple different models. To our newest technology, newest research, we're about halfway through so far. So I appreciate your guys' attention, and we can get to questions in the end, or I should finish this one and then maybe open up for detailed questions. So when I first was introduced to this research, it came through this Hamilton Spectator in an article with Mohawk College, working with school boards as part of a climate change initiative and program there. They're doing testing on this in about 12 schools right now, this technology. And upon my initial understanding and research, logically, this technology kind of makes sense. You're combining several applicable technologies that we've discussed, even UVC as well as ionization, and a few unique patents and approaches. I mean, that is a unique differentiator. If this can be proven, then it should go. And I think that's what we're watching here on this one is how it works. The unique side here that I noticed, and the first term when I learned about it that really stuck out, was the hydroperoxide concept with the ions. It's called the Remy Halo, produces hydroperoxide, which essentially activates the air. This technology doesn't just work in the air duct like a UVC would, where it has to pass through it to kill it. This technology fills the air with activated ions that have shown, interestingly, to provide a 3-foot sneeze shield. There's a picture in their marketing material of a child, an infant sneezing, and this is their article. So there are several options available based on the CFN and the application of your equipment. I think this is ever evolving, and there's some questions for sure that arise in my mind based on this new technology, particularly with regards to the activated air, and I mean the effectiveness of it. Ultimately, science is showing it's 99% effective with all sorts of viruses and mildew and mold and different strains. what does that do? Like, how is that exceptionally healthy in your lungs as well? So these are my questions about it, as well as product lead times and fit up applications is where we're at this portion of the technology. These are different applications. The left hand one within the black is good to about 6,500 CFM. It lasts about 3 years, which is great. And you can install it in the duct or the plenum. Again, this activates the air. The top left two are for far bigger sizes. Ultimately, I believe the commercial PHI, the one that looks like a duct, that'll go up to like 250 tons, which is hundreds of thousands of CFM. This is for big air handling equipment, and I believe the light commercial one is again for around about the same size. The example in the bottom right corner kind of shows how it works. The air goes through it and comes out purified and activated. Here's a summary of it all. Keep in mind this is by our step 3 manufacturer. This is a screenshot of what they've provided, but it's a great comparison to if we look at the UVC in kind of in the middle right and go down. We look at the bipolar plasma needle point. I mean, we discussed all 3 of those, and they all fit similarly amongst them. And then this third one, this Remy. And you can see which one you're getting for what different purpose. Hopping out of high tech and back into the basics, standalone portable units, I believe are a simplified solution where I'll just bring up some pictures of some of them. If you're in a classroom, perhaps a Dyson or big office space, a Dyson humidification system would be good. You have to monitor your humidity level and make sure it's between 40 to 60%. But that will work, as the air gets drier in the winter. There's some smaller ones I have along the bottom here, Honeywell ones. You can buy those at Home Depot. Then a couple bigger Honeywell ones in the middle. These go up in your duct, the one dead in the middle. And that is like basically you put it up in your ceiling tile and it recirculates the air. And I believe there's a UVC light in there, and it will basically kill the air inside your space. On the right-hand side, this is for multi-rooms. So these are affordable solutions, depending on how you want to apply them, as well. More commercial, obviously. I'm going to roll into basically a summary of takeaways for your heating and air conditioning and your building automation systems. All of this around fresh air, and this is essentially summarized from ASHRAE's building reopening guide as well as the school reopening guide. So number one, assemble a building readiness team or a building health team or a pandemic response team. I think many companies out there had to do some form of this anyway, and just start evaluating. Start thinking about your cleaning supplies. I think we got through all the baselines of that, and masks and washing hands and whatnot, and now start considering evaluating all your fresh air focused equipment. Document your findings and evaluate the sequence of operation to maximize fresh air. Careful engineering should take place to avoid damaging any equipment. And we're providing for a local school board pandemic mode demand ventilation sequences. Again, a comment on equipment safety and also implementing eco mode. So when you're unoccupied and you want to save the energy back, hit your button there. Other items were performing and reconfirming air balancing with a verified or certified tab contractor. If you fit up spaces or say you've repurposed spaces within your area, you should really consider the air balancing as well. And you do facilitate with air balancing, your control contractor if you have it there, and your HVAC contractor as well. And it's not a bad, periodic preventive maintenance measure either. Consider increasing your air filter quality and the frequency of changes. If you're changing it twice a year, maybe think about 4 times. If you're a condominium owner and you're in a heavily constructed area with dirty air, if you're doing it 4 times, think about 6 or 12. Get on the high-tech viral control measures, I think, is an important probably the most important note of this presentation is the weather's changing and you need to recirculate this air. and you need to keep it safe for the people within, I think. Consider your portable standalone purifiers, humidifiers, and HEPA filters. It is a good move, and it will help. Consider upgrading fan motors or increasing fan speeds to increase static pressure, more air, more solutions. Keep in mind the energy effect of that. As a loop through wrap up here, science is moving very fast on this. I hope to make it move faster with some of these technologies that we've discussed. Anybody out there interested in proving the science of it, we're wide open and need to for society. Engineering a methodical, detail, more slow moving group has moved very quickly. We believe that in the future of procurement, the HVAC units are going to come standard with a lot of these equipment, a lot of these viral control measures. It makes sense to put it in ahead of time. What we are concerned with here is fitting up these units or these spaces to make them safe. Governments at all levels are moving faster than ever. Ontario government just launched I believe $1 billion to long-term cares and other HVAC upgrades or COVID protection measures. We suspect that more is going to come out. I would suspect and hope that some of these measures that are discussed here will make it into those areas, and we can, this is going to be a good thing for the future. Overall, better than nothing is I do not believe is good enough. We do have to start somewhere in this process and essentially get started today. Thanks everybody, and I really appreciate the opportunity from HHCA again, Sue, Alana, and all the team, and happy birthday to happy birthday to HHCA, and thanks everybody for your time and attention. I really hope you learned something today. Any questions? Another question then. Maybe what did everybody learn here today? What was everybody's favorite technology or coolest thing that maybe they picked up on? There we go. I'll unmute everybody.
Well, it was all excellent presentation, Aaron.
Thank you.
Excellent.
Just a quick question as far as existing equipment that may be 15 years old. How retrofittable are they to the new technology?
Some of the old equipment is actually like better because it's bigger. There's more space in it. It's simpler. They're boxes of steel and big,
sheet metal,
big coils. So some of them are actually it's better and you can keep it going. Yeah. It does depend almost entirely on the equipment itself and seeing it in the application. But again, I went through several local big buildings. Essentially, I'll keep it simple as a big commercial client and really old equipment, and for the most part, it worked good, except the stuff that was about 50 years. That was a little bit too custom.
Yeah. We
did find actually on smaller equipment the UVC to be slightly cost prohibitive. Because you have to put it in the supply air duct, and the CFMs are high there compared to near the coils. But in the bigger equipment, as I've mentioned, between those coils, you get quite a stable airstream, and it's more affordable.
And just another question too, with these increased the higher efficiency filters, if they are indeed capturing or potentially capturing viruses, do the HVAC mechanics that are changing these need to be trained or made aware of the possibility of having contact with viruses?
No, that's probably that's a great question. Thank you for hitting on that point, and absolutely that was one of the first steps we had to do with our technicians who are out there changing filters every day, and yes, they have to wear their mask for sure. Probably like eyeglasses are probably important. Gloves for sure, and yeah, they have to dispose of it very, very delicately. You don't necessarily want to be shaking those filters out at all, which can happen if they're really dirty.
Yeah.
Yes, there are definitely safety precautions that the HVAC mechanics or sometimes your building operators need to be aware of. Absolutely. Now, I guess again, a second comment on the filters is like I have that slide open in the top right side, and it's a good start. It's not overly effective against it, but you are correct in that it is a contaminant that needs to be treated as such at the moment. What does everybody think about the activated air combo solution? Because again, this is fairly new to me. I would be curious to know what everybody's kind of initial thoughts were on this technology.
Well, if I could just jump in, I would say if if you're a small office with one unit, the investment is hefty to start with. But if you are looking at a larger facility, this cost could easily go crazy. If each and every unit has to be retrofit and outfitted with um, this UV and the plus plus technology, the ion plus technology. Yeah, are we talking about each and every unit needs to be retrofit, or a portion of your inventory?
That's a great question. It does depend on the layout of your ducts and how the system operates overall. I'll be clear here. I did mention the price tag for a typical UVC fit up. The ionization is lower, and at the moment I don't know the pricing on this plus plus stuff.
Hmm.
I do suspect it'll be, at least on the smaller units, be more affordable than the UVC. It's my guess. Um, it ultimately depends on the layout. I would say, yeah, you probably want, no matter wherever the air is returning, anywhere with return air, that's not providing 100% fresh air like a makeup air unit. Yeah, you should probably consider something along those lines within that unit. Yep. I, one fit up per unit again, unless it's providing 100% fresh air, like in your condo hallways. Not applicable there. Doesn't need it. What does everybody think about the research and the science and the toughness of knowing which is which? I guess that's a trust variable. How does everybody feel about that? With all this information coming out.
Well, if I could just jump in, I think where what I'm gathering from this is, theoretical sounds like it's going to work. Practical, I think we still need to have some practical applications, and then have some information, some data back, based on the effectiveness of it, I suppose. I still think that right now everyone's reacting and it's still in its infancy. On paper, it sounds great, and in reality, I'm not sure we're there yet as far as the effectiveness on it.
Oh, sure. And I agree with that. And, you know, each system needs its own science behind it. And it has to be proven in different scenarios as well. And I mean, I think that's going to be the hardest challenge. And I alluded to that in a few of the technologies is how do you measure this? What is too much? Is there too much of a good thing? Can you over ionize it or whatnot? Um, I think that those are the questions that us as installers have as well in this process, and what is the safe measure and what will be effective, in particular against COVID. And the other piece is, and I've heard other people say it's not from me, you know, it's bonus for the future. Some of the stuff, I mean, it shows it's the combo solution has proven 20% drop in absenteeism across other school boards in the U.S. So there is some science behind it all. It depends on what we're trying to do here. Are we trying to help our air quality? Are we trying to, fry COVID? Or are we just trying to make this safer? I think that's ultimately kind of part of that research-based question. Now, what I can tell you on that note is exactly what I'd mentioned. Be very, very diligent on it, because some of it, especially if it's sold to you without diligent research, it's not going to do anything, and it can cause, false confidence in your safety, which can cause a lot of bigger problems. So, to the same point of it all, I think that's the measure here is we, avoid what may or may not be effective, or what is just a sales gimmick. I think that's an important message that I've hoped I've delivered here is just be aware. because it's out there, obviously.
When I first came to this country, one of the words I had was cutting new ice. This is exactly what we're doing here, cutting new ice. It's going to be a hard sell, but a worthwhile sell. Cutting new ice, that's what I think.
It might have been real cold when you came over here by chance, eh?
Yeah, but the thing with all that was the word we had. And we were saying, what the hell does that mean? We come from the land of heather and Greenland, no ice. But now I know.
No, and Peter, you're exactly right. This is exactly what this, what this is all about. It's all about learning and staying in touch and
Yep.
staying on top of it. And I hope that, I can stay on top of it for everybody in this meeting and other people who, get to watch this webinar as time goes by.
Yep.
Aaron, one of the two issues actually that came up when we were closing the sale with one of the school boards that we worked for recently was what legacy values can these upgrades have? Assuming that at some point in time in the future that we'll get past this COVID crisis, and I think that's a really important consideration in proposing solutions like this. And so, in thinking about that, we came up with a couple of strategies. From a building automation perspective, is once we integrate the controls deeper into the equipment, whether it be packaged or built up equipment, is that we can add in new strategies because we have all the points now and we have access to all the end devices. Strategies such as typical morning warm-up strategies where you leave the economizers closed until the space comes up to occupied temperature, both summer and winter. Simple as that is, it's rarely applied in sequences of operations in a standard spec, and so there's lots of opportunities there. Another area that came up is obviously on the CO2 demand ventilation, which is a component of managing energy while we are in a high ventilation mode to deal with COVID. It again can provide legacy value once we get over the hump of COVID into the future. So, and these are things that we've got software solutions in-house that we can develop payback plans or payback exercises for the clients. But I think a lot of the holdback on having organizations invest in this is there's still the thought that this is just a spot in time that eventually will pass, and that if there's a resistance to make a large investment in upgrades, in a situation that in a couple of months or maybe a year or so may pass, and then that investment is lost. So that's a consideration that we brought to the table in our proposals, and I would suggest anyone that's listening to this take note of that as well.
Yeah, no, thanks. That's those are good details towards the process of this, and I guess I'd say what I think is really the legacy value of these things that you mentioned. There are things that are really good and really capable of building automation systems and good applications of it. I think it's why building automation systems were created ultimately, is to be able to do these types of things. And we know they're being underutilized, or under leveraged a lot of the time. So that that's a good comment towards us. We got about 7 minutes left, at least based on records here. I don't need to hold anybody here. I really appreciate your interest. If there's a few people we haven't heard from, if there's any thoughts that you guys have, we'll leave it open for a next little stretch here.
Okay, then I'll say my goodbyes. Thank you for the presentation. It was very informative, and we'll look forward to the next one. Thanks, everyone.
Thank you very much. Have a great day.
Yeah, you as well.
All right. I suppose I should draw this to a conclusion then. I will have this. It's been recorded. We'll chop out some of the dead noise while we're waiting for people or to I guess get the courage to pop up. And if nobody has any more questions, I'll end the recording, and everybody have an excellent day.
Thanks, Aaron.
Thanks, Aaron. That was good.
Thanks, Aaron.
You're welcome.